This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 6, Lesson 2, GD&T, Part 2. Part 1 gave us the vocabulary. Now comes the payoff. Virtual condition, the handbook's printed worst-case boundary that decides whether two parts mate. We run 4 worked problems: sizing a functional gauge pin, classifying a hole and plug fit, working a true position error, and deriving the maximum material bonus tolerance. Concept: virtual condition. It's the worst-case boundary a feature occupies once you fold in its maximum material size and its geometric tolerance. The handbook prints the rule. For an external feature, add the tolerance to maximum material. For an internal feature, subtract it. Get maximum material right first. Largest for a shaft, smallest for a hole. Parts mate when the internal boundary is at least the external one. Setup: 4 calculations, all resting on virtual and material condition. First, size a go gauge pin for a pattern of 4 holes. Second, classify the fit between a hole and a plug, each toleranced at maximum material. Third, turn a coordinate offset into a true position error and its diameter zone. Fourth, show how maximum material unlocks bonus tolerance as a hole departs its tightest size. Solve Problem 1. The go gauge pin is machined to the hole's virtual condition, the smallest boundary the hole must clear. The hole is internal, so subtract. The maximum material hole its smallest size minus the position tolerance gives about 7/10 of an inch. One pin that enters all 4 holes checks size and position together. Solve Problem 2. Compare virtual conditions. Internal subtracts, external adds. The hole's boundary works out to 0.78, the plug's to 0.80. Guaranteed clearance would need the hole boundary to be the larger one, but it isn't. The plug boundary is 2/100ths bigger, so the parts press together. Interference, even though the nominal sizes looked like clearance. Solve Problem 3. True position. The actual axis lands off the true position by 3/1000ths in one direction and 4 in the other. The radial error is the hypotenuse. A 3-4-5 triangle gives 5/1000ths. Because the position zone is a cylinder, its diameter is twice that radial error, 10/1000ths. The axis sits right on the zone edge, so it passes only if the frame allows a diameter of 10/1000ths or more. Solve Problem 4. The maximum material bonus. Position was called at maximum material, so when the hole is cut larger than its tightest size, that extra material is free to absorb position error. The usable tolerance is the stated tolerance plus the departure from maximum material. At the tightest hole, there's no bonus. At the largest, the full 10/1000ths size band adds on. Position grows from 50 to 60/1000ths. Regardless of feature size, would grant none of this. Traps: 5 ways the arithmetic bites. 1. The virtual condition sign flips. Add the tolerance for an external feature, subtract it for an internal one. 2. The gauge is the virtual condition. A go gauge pin is machined to the hole's boundary, not its nominal size. 3. Maximum material grants bonus tolerance, regardless of feature size, gives none. 4. A position zone is a diameter, not a plus or minus box. The radial error is only half of it. 5. Get maximum material right for the feature, smallest for a hole, largest for a shaft. Quick recall: get maximum material right for the feature, then build the virtual condition. External adds the tolerance, internal subtracts it. The gauge pin is the maximum material hole minus its tolerance, about 7/10. A hole boundary of 0.78 against a plug of 0.80 presses together. Interference: true position, radial error is the hypotenuse, and the zone diameter is twice it. Maximum material grants bonus tolerance equal to the departure. The virtual condition rule and the maximum material definition are printed. The true position formula and the bonus rule are derived from the printed definitions. Next up, Topic 3, Engineering Economics. You can read a drawing and prove a fit. Now the course turns from drawings to dollars. It moves money across time, present, future, and annual worth, the interest factors, effective rate conversion, and the depreciation methods. Everything's at peprepengine.com. Cheat sheet, work solution, and a quiz attached here. If the course helps, subscribe.
The full study guide with every equation and common exam trap is free at peprepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.